live soon.
Cool. Yeah, I see the live dialogue pop up.
Woo! I'm gonna refresh on YouTube. Takes a minute. There's like a 30-second delay or something like that on YouTube. So,
Hmm.
um, yeah, I think it's something about probably video quality. Like it probably goes through some sort of encoder thing, and they make it look better.
Uh, yeah, and it's probably buffering too when it sends it to people. At least I notice when I'm watching videos, like it wants to buffer as quickly as
Oh yeah,
possible, and then
yeah.
give you, which is smart.
I
It's
see. I
good.
see a few people here already. Hello, everyone. We're waiting a few minutes to get started because we're a little bit early, but it's always fun to hear like where people are watching from. You know, why you might be interested in graph query languages or any other questions you might have for Jason. Feel free to start putting them in the chat. Again, bare minimum. If you just want to say what city or state you're watching from or country, it's always just cool to see like where people are. And we were just talking before we started about all the different versions of the YOLO, which is like a computer vision algorithm for object detection, and we are just like, there's already a new version. Swear, it's like unless was V7 already like a year ago, and time just flies by. That might be the case
Was
too.
it?
I
So
don't know.
I was searching this morning, right? Because I was getting, I was seeing some posts about YOLO 5, and then like, oh yeah, doing something on 7, and then I saw an ad for what was it like Rocket Lab? No, some company that was like, hey, we've got a thing with V8, and I was like, V8 already? So I tried to look to see on YOLO, tried to find YOLO's official site, and clearly I wasn't on the official site, but whatever I was on was like V7, it's the latest, and I'm like I don't know what version it is.
I think also at some point, I could be wrong. I feel like it was a different company, maybe was managing YOLO like a while ago, and then it might have switched. Because now I think it's Ultralytics, but I could be
Yeah.
wrong. But I think at some point it like switched from some other company or it was completely community driven or something to now there's like kind of a company behind it. So
Mm.
that also might be part of the confusion if there's like almost like two things going on with YOLO. Could be.
Yes. I have to take so the my goodness, names are totally dropping out of my head right now. But someone had posted on LinkedIn. Salik, I think is his last name. He's the
The
CEO.
OpenCV CEO.
OpenCV, yes, yeah, OpenCV guy, and he was showing a clip of it looked like an action film. I think it was like a Jason Bourne movie, and here's YOLO. I think it was for YOLO 7, tracking all the characters running and identifying boats and cars and stuff as they were passing at an incredibly high frame rate. And it wasn't doing just object detection; it was doing segmentation detection. So it would, you would see the outline of the object that it had identified at this very fast clip, and it was just, it might have been post editing magic as well too, but it looked phenomenal, and I do believe it was real time inferring.
That's awesome. Yeah, he's great to follow. And OpenCV, they always have really cool demos and stuff they show off, and it's a good way to keep up with some of the latest of the computer vision stuff for sure.
Mm.
I know we're at 10:30 now, so I'm going to go ahead and do quick introductions, and then we can get into some of the questions. Let me just set up my screen real quick. And again, for anyone just joining, let us know in the chat. Say hello. Maybe where you're watching from. It's always cool to hear, like, what's going on with people that are actually watching live. But I'll get into quick introductions. My name is Sage Elliott. I'll be the host for today's Robust and Responsible AI event. If you didn't know, we're a community of AI and machine learning practitioners, researchers, designers, and much more. Kind of just a whole community working around data and AI. You can think of today's event kind of as a live podcast. So I'll be interviewing guests starting with a specific topic, and then we might have some time for questions at the end. And I always encourage you to post in the chat throughout the conversation and connect with each other. Like one thing about going to live events, even if it's online, is it's fun to kind of connect with other people watching, which is really cool. There's also, I think, a link to a Slack channel in the description. So if you want to stay connected after the event, it's a good place for that as well. And there's also a link in the description for an event happening on January 26th. We're actually hosting a whole summit where we have a whole bunch of speakers. One of them is Andrew Ng as well, which is really exciting. So if you want to join that, link is also in the description below. And today we have our guest, Jason to talk with us about graph query languages and graph databases. And before we really get into those topics, could you let us know a little bit about yourself, Jason? Maybe a little bit about your background, how you became interested in data and ML or got into the field, and then a little bit about what you're currently working on.
Sure. Hi, everyone. My name is Jason Koo. I am a developer advocate over at Neo4j. And Neo4j is a graph database company, which we'll get into a little bit more later. So my background is actually in mobile app development. So I started doing iOS development, I think back in iOS 3 when that came out. And I did that for many years, eventually did mobile SDKs. And then I moved into developer advocacy. And one of my first developer advocate jobs was with a computer vision company, which is also how I ended up meeting Sage through some ex-coworkers. And so computer vision was my segue into the machine learning and AI space, right? Because computer vision is one of the several pillars of AI development. And I love computer vision, and we were just talking about it a little bit earlier. I do wish I had more time to kind of do computer vision projects. So I am always looking for a way to marry a computer vision project with a graph database, which isn't too hard. I just have yet to find the project that's really going to consume me. Oh, hello. I guess Peter from Virginia, and is it Keep from Netherlands? Haven't been to the Netherlands, but Virginia, beautiful state. I love that state, especially in the fall. Okay, yeah, that's probably me in a nutshell.
Real quick, just to add on, what is a developer advocate?
Okay, yes. I forget because I've been doing it for a number of years. So a developer advocate is not a new role, but it is kind of a new role in terms of like kind of mainstream knowledge. And I think the role began at Google. And so the space for developer advocates is kind of that intersection between engineering, product, and marketing, right? That overlap where you have a developer-centric product or a product that has like a developer component. And developer advocates are basically tasked, or they work within the space of building communities and helping developers of a given product or a given tool and helping that community grow, right? So whether it's moderating forums or going and promoting and doing talks at different conferences. So it's all the it's I kind of like it's kind of the, if you're an extroverted developer, it's the fun parts of development, right? Where it's after you've built a product or built a tool and then going and talking about it and connecting the dots with other folks. That's generally what a developer advocate does.
Yeah, sometimes you get to build really fun projects as well. And I like to say sometimes you get to build really cool project, but then you don't have to worry about it like being maintained in production. Depending on your use case, I'm sure some people do, but yeah, it's fun to like you get to really experiment and build something awesome and then like share it with other people and in a whole bunch of different ways.
Yeah, not having to maintain it afterwards is a definite plus, because it's a lot of projects from DevRel folks is or at least me is very it's duct taped together and it's like it works, but you definitely don't want to take that into production.
Awesome. All right, so let's get a little bit into the graph database area. Before we talk even about the graph query language, could you explain what a graph database is and how it differs from other types of databases? Maybe why we would want to choose a graph database over like a more traditional database?
Right. So probably most folks here are aware that there are many different kinds of databases. The most popular being, a relational database or an SQL database. So the biggest difference from a graph database compared to a relational database is you can think of a graph database as a super relational database, right? So when you have a data point, which is going to be like a node, like say a person and I don't know, a car, the relationship between that person and the car, right, provides you context, right? So either they own the car, they're leasing the car, they built the car. That relationship data is part of the data store, right? It's a first-class citizen along with the person data and the car data. So this data typically in a relational database is transitory, right? It's ephemeral. It's not permanent. It has to be created during query time, unless you're creating a bunch of like in-between tables. So because graph databases store this data as a first-class citizen, you can traverse relationship data very quickly and do all sorts of interesting graph algorithms and graph data science on top of that. So that's the big difference between a graph database and pretty much all other databases.
Is there a use case out of that that maybe is one you often pick to kind of explain why, like one, like what, like a social network or something with a lot of relations to each other, kind of like the graph database, like you said, it's kind of all these nodes and they all have relationships with each other. Is there a use case that often comes to your mind when you're explaining it?
Yes. So any sort of problem where you have a lot of interconnected and seemingly unrelated data is a great use case for graph databases. So my introduction to Neo4j was through the Panama Papers, which was this huge public release from the ICIJ back in 2006, 16. It's been a while. But basically what they had been given was this huge data dump from this law firm that had all these transaction records from very very famous, very powerful people, and them hiding their money trail. And so the ICIJ put all this into a graph database, Neo4j with some other technologies stacked on top to make it easier to interface with. And what they did was they basically, connected all the dots. And so the investigative journalism use case is a great use case for graph databases, where you have a ton of data that might seemingly not be related, and being able to traverse that data to inspect it, analyze it, and kind of connect the dots, right? Because you can infer connections between nodes that you don't have direct relationships, right? So you may have, this person is doing some sort of activity, another person is doing another activity, and there's no explicit connection between them in the data that you currently have. But by analyzing all the data around it, a graph database can infer like there should be a relationship between these two people, right? And then so that can give you leads of where to investigate to kind of figure out if that connection actually exists. So yes, investigative journalism is a huge one. Social networks, as you said. So if you want to build your own personal, Twitter, building it on a graph database is probably where you want to start. Big pharma for drug discovery, it's really useful for. That level of science is way above me, but I have heard many people explain to me how they use in a digital form inside a graph database, discover new compounds that will have particular effects before they even make it and begin testing on folks. And then fraud detection is probably one of the biggest things, right? Because, abnormal behavior or abnormal data is very apparent in graph databases, right? Because to make data look normal, like all your other clumps of data, you have to not just affect one table, one row. You have to, it would be like trying to change data in a hash table. You would have to go back to a certain point and then change all the downstream data that was relying on that early hash. So that's just a snapshot of use cases you can do with a graph database.
That's awesome. Those are some cool use cases that I didn't think of before, but I mean, totally makes sense. Like you're saying, big pharma or pharmaceutical applications where there's so many different relations between like drug compounds and proteins in your body and stuff. And yeah, that's very interesting and a cool use case I hadn't thought of. But it makes sense because so many things are graphs, but they haven't always been represented as graphs until I feel like now there's a lot more graph database adoption happening. And it's cool to see this happening.
Yeah.
All right, so we're going to talk about, I think, the graph query language and how that can actually help enhance the capabilities of graph databases. Could you tell us a little bit more about that?
Okay, so yes, the graph query language. So right now, there is not a standard like SQL, but there is an ISO group, working group that is in the process. They're about halfway through in proposing a graph query language that will be a standard that all other graph query companies should adopt, or at least have some sort of integration with. So the reason for having a graph query language is other query languages aren't as capable of traversing graph data in an easy to use manner, right? So this is probably easiest to describe for someone who is very knowledgeable with SQL databases. And if you ask them to, give you data like find all the people that somebody likes, that is a fairly straightforward, very simple SQL query. But if you continue that pattern, like give me all the people that the person who likes the person who likes another person who likes another person, based on a limited criteria like that also happen to drive the car that you drive, right? These sorts of the more complicated these patterns are, becomes a very complicated SQL query. But in a graph database, a graph query language is usually set up to do patterns, right? So you can do pattern matching fairly simply in a graph query language. So Cypher, which is one of the kind of the contributing languages to GQL, and it's what's used at Neo4j. When you want to look for a particular pattern, you would write it as kind of basically ASCII art, right? So you start with a keyword match, and then you have any node would be surrounded by a paren, so like person, and then a dash, and then brackets, the relationship type, right? So like likes, and then dash to another paren, which is another node object, say car, right? So person likes car. That is basically one of the simplest patterns you can look for, right? Basically an object, predicate, verb, contained unit. But you can keep going with this pattern in probably a way, in an inherently predictable manner, right? So if I want to know who likes this car, and I want to know who also likes this car from Virginia, right? You just keep making that pattern longer, and then you run the query, and it will return you the results for that pattern. All right, so that's probably the biggest reason to have a specialized query language versus using some other language off the shelf.
Yeah, and having a standard way seems pretty important, as there's a more and more adoption of people using like graph databases. Just like
Yes,
we have
yeah.
SQL, like you were saying, right? Like if you've worked in a SQL database, like everyone knows there's SQL. There's a lot of documentation on SQL, and a lot of work went into it.
Yeah, no, totally. And just a little more information on the graph query language that's in the works. It fortunately it wasn't set up by just one or two companies. There are representatives on the working group from a number of different companies and a couple universities. So Neo4j has a representative there. Oracle, Google, I believe, had someone, but I don't think they're on the current working group. Tiger Graph, maybe Arango. So quite a few of the most well-known graph database companies have a hand in the jar, have somebody there to help with the cooking of GraphQL.
Awesome.
Oh no, of graph query language. Okay, so yes, that probably leads into the next logical question.
That was gonna be my next question anyway. So this is perfect. Could you compare and maybe like contrast those two languages? So even when I was reading it, like GQL, that's the graph query language, and then there's GraphQL, which maybe a lot of people have heard of. And could you like talk about the differences or the unique features between those?
Yeah, totally. So this is, I just made that mistake. This is when I run into a new developer and I make the poor assumption that they already know something about graph databases. I go, well, how much about graph databases do you already know? So that I'm not mansplaining anything to you. And most of the time I'll get an answer that's like, oh yeah, I've played with GraphQL with a Postgres database or some other SQL backend. And that's not correct, but it's a very obvious sort of conclusion you can get to, because GraphQL has become this very, not quite ubiquitous yet, but it's more and more people are knowing about GraphQL. And GraphQL, for anyone not familiar, is it's easiest to describe it as a REST alternative or better REST, I would like to think. So in GraphQL, you create a query that's in basically a JSON format. And when you fire that off, the GraphQL server will return to you your answers in that same format that you basically sent the query with, right? So, with REST APIs, you make an API call, and then you get this giant dump of data, right? That's, hopefully in JSON or some other format you can work with. But then you've got to parse through that JSON data to get what you want. And then very likely you have to make a few other calls to get, kind of pick together all the data you want into this one JSON object that you do want. GraphQL, which was developed back at Facebook, I think 2012 by a few folks. And it was made open source, I think 2015. And anyways, it's kind of taken off on its own. So when you fire this query off to a GraphQL server, you get back that JSON payload that you ultimately, presumably, wanted for your app to work with, right? So it does away with a lot of unnecessary data, right? Because if you have a device like a small phone with limited bandwidth and you're making all these giant REST calls and getting all this data just to filter stuff, it's much more efficient if you make a very targeted GraphQL call, get that data you want, get back, and then go from there. So GraphQL, which is a REST interface, which is separate from Graph Query Language, which is used to traverse and kind of do data analysis within a graph database, right? There are simple query commands you can do to give you data that's similar, that you could feed into like a REST endpoint or to a GraphQL thing. So you can have both, but they are specialized in two different areas, right? One is GraphQL is general purpose for interfacing with external applications. Graph Query Language is for interfacing with the graph data directly and traversing it. So that's the differences in a nutshell. Interestingly though, so GraphQL has a foundation, right, to support it, and Neo4j is one of the foundation members for that foundation. So Neo4j supports the development of GraphQL.
Of GraphQL or GQL?
Of Graph. Okay, so kind of both in a way, right? So there isn't yet a Graph Query Language Foundation, as far as I'm aware. But Neo4j does have a representative to help with that working group. But Neo4j is also one of the foundation members of GraphQL. So we have developed a GraphQL toolbox to kind of help put a GraphQL front end to interface with a Neo4j database, further making everything more complicated, right? Because we got GraphQL, Graph Query Language, and a Graph database. So, but yeah, in a nutshell, the GraphQL and Graph Query Language are different, but they are within somewhat similar domain spaces.
That's awesome. Great explanation. Thank you, because I know that cleared up some confusion I've had in the past for sure. And I can see why people would easily get confused because they have the same abbreviations. Except for GraphQL is always called GraphQL, not GQL.
Yeah, right. It's the topic or the discussion of like, oh, we should have named this or that something else, like graph databases. I've heard a number of folks wish that the whole space was named something different, but I honestly don't know what would be a better name. Anyways,
I also saw a question somebody asked first they said sounds interesting, and then they asked, do we get to see a demo in this session? I don't think there'll be a demo. This is just us kind of having a conversation today. But all of Jason's information is in the description, and I don't know if you have a best place to see a demo, Jason, you want to point people to, or if they want to connect with you and ask more about it. What's the best place to do that?
Yeah, you can reach out to me directly, and then I can send you like relevant demos that you might be interested, depending on what technologies you like to work with. But in general, Neo4j does have a regular YouTube channel that just kind of explores random data sets with Alex and Michael, two of my coworkers who are way above smarter than me, and they're like, pretty much every 2 weeks they are grabbing some new data set and go like, okay, this is how you could throw it into a graph, and this is the sort of information you can glean from it. So yeah, I would look at YouTube Neo4j's channel to start with if if you don't want to reach out to me.
Awesome. And yeah, the links to Jason and Neo4j, you can look in the YouTube description, and I'm sure you can find what you're looking for there, or reach out to Jason on LinkedIn. All right. So moving on, are there any ways in which like graph data is structured that like supports anything interesting in the field of machine learning or AI that you find exciting?
Yes. So in a nutshell, right? So a graph database graph network is in the same shape as a neural network, right? So taking graph data and putting it into a machine learning pipeline is, I don't know if it's seamless, but it's very easy, right? So there's a whole space of graph machine learning, graph neural networks. And if you're coming from a traditional machine learning background, probably the easiest way of looking at graph data in terms of coming into your existing pipeline is I've heard it described as basically you can convert a graph to an adjacency matrix, and you add that as part of your initial input layers, and go from there. So having graph data as part of your training data is super helpful because it brings in that contextual data that's in a graph that makes graphs so powerful that you may not get, or you're not going to get, if you're using purely tabular data from disparate sources that you're not sure if they're linked or not. But in a graph, when you're pulling in those graph data or turning them into graph embeddings, then you're enriching your initial data set.
Yeah, so you're basically preserving these relations to these nodes that you might otherwise lose.
Yes, and the great thing with I presume all graph databases, but especially with Neo4j, is you can pull it right from that data store, right from the source of truth. So you don't have to look at disparate tables and noodle together what that data will look like to create like a feature set. You just just grab that data and just put it right into your part of your training process, and you're good to go.
That's awesome. All right, so we've mentioned Neo4j several times, and you've talked about working there as a developer advocate. Sounds like there's a lot of really cool stuff happening. Could you tell us a little bit more about Neo4j and maybe the work that you're doing there?
So Neo4j, as I said, is a graph database company. So we offer a graph database technology for other people to use, right? So we've got a community edition and an enterprise edition, both of which you can use locally for development. And for the machine learning space, for data scientists in particular, there is a package that we've created called the GDS, the Graph Data Science Package, which you can just tack on to. It's a plugin that you can tack onto a Neo4j instance. And what it does is that allows you to do the graph algorithm, the interesting graph algorithm stuff like community detection, page ranking, nodes or relationships, centrality algorithms, and finding shortest path between things, and the link prediction, which we talked about earlier, right? Like churn prediction, right? It's a huge machine learning use case. If you want to know if somebody's going to churn in the future, part of knowing that is, you want to know who somebody knows, right? Because often if everyone around someone is churning, then that person's likely to churn too. But you can, because the relationship's important, you can also use link prediction to determine like, oh, this person is or isn't related to this other person who's churned, right? Like you may not have explicit data that says that, but you could have a graph database tell you like, no, I'm pretty sure these two people are connected. You just don't have that data. You should go find it, but we can do a prediction based on this hypothesis that they're connected.
Nice. That's really cool. What a really cool use case. Something I haven't experimented that much with yet, but I'm excited to build a project around it. If you ever want to do maybe a side project together, let me know.
Oh yeah, no, that would be totally fun. Yeah, especially if we can loop in computer vision.
That would be
There
awesome. Yeah,
is
we should do a computer vision Neo4j workshop.
Yeah, that would be my there. So not every Halloween, but we, for years, every Halloween, I'd bring out this old project that ran a computer vision um, app on a Raspberry Pi, and I put it in this like scary pumpkin thing, and it would look out across the patio, and anytime somebody would walk by, granted it could tell it was a person and not like a horse, um, would basically yell at them, like, hey, you over there, why don't you come on a little bit closer. And when the person got close enough to this contraption, it would basically spit out candy, be like, here you go, blah. um, so I've always wanted to kind of clean that up and make it publicly available so that everyone could create these, interactive candy dispensing devices.
That sounds really fun. I think I remember seeing you talking about it on a happy hour once, like an IoT happy hour live stream.
Yes. Oh yeah. With the Belena guys. Yeah. Yeah.
Yeah.
That's a good group too.
Awesome. Well, I know we're getting basically we're at the end of our time here, but I wanted to ask: are there any trends or advancements in the field of data and machine learning that you're particularly excited about? Maybe outside of graph databases, because we know you're super excited about that.
Yes. So I mean, like everything, Chat GPT, right? Like everyone's talking about it. It's blowing up, and everyone's doing some interesting things. So I'm really like excited to see the further downstream effects of technologies like Chat GPT being integrated in other technologies, right? So I think one of the things we'll probably likely see is the ubiquitous search bar being slowly upgraded or replaced with something like a Chat GPT interface, especially for like complex analytics and stuff, right? So a lot of analytics tools right now is like here's all the data, you figure out what meaning you can get from it. But having something like a chatbot system that's looking at the data and can summarize what's happening, and having that as part of a product, right? So things like that. That's what I'm really excited is to see more AI, more machine learning stuff that we've all been like talking about and all been working on for the last couple of years, starting to really show up in a more noticeable, more powerful way in products.
Yeah, actually coming out in those products, like you said, being deployed where we can interact with them easily. I think that's one thing that made Chat GPT so cool too, is even though it's not exactly tied in to like a regular search engine yet, but it's in a really easy to use interface that's awesome and people love it.
Yeah.
And I've heard rumors, or I saw an article that was talking about probably bringing it over to Bing, which I could totally see. I think like you mentioned, this will kind of change the way we might interact with search engines. We might still get those lists like we get with Google and Bing, but we also might have a chatbot also kind of giving us more of a conversational output, which I think is pretty interesting.
Yeah, right. Because the sort of narrative output's easy for people to read and follow. The only thing maybe it'll be added with the Bing version, but is an attribution, right? So when you ask ChatGPT something, it spits out an answer like you're talking to someone, which is great. But oftentimes, like I would like some of that information cited, right? Because we know ChatGPT is not 100% accurate. Nothing is really 100% accurate. So you kind of have to go outside and kind of verify what it's telling you to weigh how valuable that data is.
Yeah, it's you have to kind of have an intuition on it right now too. Like, I mean, you should expect that it's not going to be correct, but there's something. Same with search results. Like you're kind of browsing for what you're looking for, and using Chat GPT right now, I find that I'm like, okay, I have my gut instinct kind of if this is actually accurate or not. Like if I'm asking it to write, like I was experimenting with it to write some code to see what would happen, and you got to be like, nah, there's got to be a better way to do this.
Yeah. No, totally. Yeah. Yeah. It's good for like, I think like getting you started. But something I think a lot of people don't realize too is I think ChatGPT was only trained up to data up to 2021. So you can't ask it for like, what are the 3 best whatever products, like any sort of question like that. It won't have an answer for you at this time.
Right. I did see someone ask a question. Are there any job opportunities at Neo4j? I don't know if you have any specific job listings you want to shout out, or just a place that people can go find out.
Yes, yes. So we have a careers page. I'm not sure. I guess I could pop in real quick, but it's basically neo4j.com/careers, I believe.
Try to pull it up real quick. Well, while we're pulling that up, is there anything else you want to share about your work, Neo4j, or any other topics you think would be relevant or interesting for people while we're kind of just wrapping up here?
Yeah, we've got a ton of content. But I would definitely invite everyone to just try using a graph database, whether it's Neo4j or another one. Most of the major companies that I'm aware of have like a free tier or free cloud instance that you can just spin up. You can load with mock data and just start playing with it. One thing I've been playing with, so one of my most recent projects was building a mock graph data generator, right? Which the exact opposite of fraud detection, which is basically trying to create a fictitious network. So the reason I was building this project was when I'm talking to folks and explaining, like, oh, this is how graph database, could help your company. And conceptually, that gets across easy enough. But it's there. You only have that wow moment when you see like your data or data that looks very much like yours, and then seeing the value from that, right? So oftentimes, data for at least, like consumer applications, that data is usually not publicly available somewhere. Or if there is a data set, it's super old. So I built this tool that based on your UML diagram or your properties, will generate a bunch of mock data that's interconnected, just so that you can play with a graph database and get a sense of what your data will look like in this form. So, sorry, long story short, the best way to really see the value of graph databases is to get some sort of data in there that you care about, and then just start poking around. One of the great things about graph databases is data discovery. You will, once you see connections between different data, you will see things that you didn't even know to ask for before. That's probably it's one of the great advantages of traversing data in a graph.
Well, I'm excited to try it now.
Cool. Awesome.
Does anyone have any other last questions for Jason? Otherwise, I think we're going to wrap up the stream. I know I'm already over the time that I booked with you, so thank you for staying the extra 10 minutes.
That was great. Yes, I could talk with you all day, so it's good thing you cut me off.
Well, we might do something else in the future. It sounds like there was interest too of like a demo, or like we had talked about, maybe building a workshop thing. I think that would be cool if anyone's interested in maybe doing graph databases with computer vision. That seems like a fun topic for sure. I'm excited about it.
Yeah, no, that would be fantastic. We got a long time before Halloween, so
that's right. We should start working on a Halloween project. Otherwise, I'm going to go ahead and end the live broadcast now. So thank you so much, everyone, for tuning in and saying hello and asking questions. It means a lot. I'm going to go ahead and end the stream. And if you want to stay connected, again, all of Jason's information is in the description on YouTube. And you can also connect with other people in the Slack channel that I mentioned that's also linked below. Thank you again. And we'll go ahead and end here.
Thanks, everyone.